Okay, Phil here. Today I'm going to be trying to make a couple Big Muff pies. It's kind of a fuzz style distortion, and I'm going to be making it on what's called Stripboard, or one of the brand names is Board. And the way that these circuits work is you use one of these boards that has bus lines on it that go one way. You can see them going across here. And so by breaking these bus lines, or cutting the circuit along these bus lines in various spots and running components across them, you can create a circuit relatively quickly. Now, the color's a bit off here, but the layouts look something like this. And you can get tons of these online for various effects and other electronic projects. And basically it tells you where the components go, as well as where the bus lines need to be cut. Those are these red squares here, as well as where there need to be jumpers across the bridge line, or bus lines, sorry. So you can see here it says 17 cuts and 5 links. So we break the bus lines in these 17 places. We run links or jumpers across these 5 places. Then we populate the components and connect all the auxiliary hardware, like I think there's 3 pots for this, a switch, and of course the jacks and power and such. And this will be a clone of a Civil War era Big Muff, which is a pedal I very much enjoy. So the first thing to do is figure out how big of a board we need. Now, I've got these large ones, or large-ish. You can get these off of any electronics supply, really. It can be a bit hard to navigate the inventory on some electronic supply shops, so you can also get these off of Amazon. I got a bunch of different sizes in like bags of 10 off Amazon, and they're relatively inexpensive there. And shipping's great. You can just tack them onto another order of something else that you get from Amazon. So once you figured out the size you need, which we can see here, we need 19 by 17. And I've already checked, we need 19 spots along the bus line, or running the length of the bus line, and we need 17 bus lines. So we have more than enough space on these boards, but we don't want to have too much extra. So we'll cut these down to size. You can do that with a Dremel. You can do it with there's small table saws you can get. I have a bandsaw that's intended for wood. That it doesn't make the cleanest cuts, but it goes quickly and it's easy. And I'm going to run out to the garage and cut these to size, and then we'll continue on. Okay, so here we have the Vero board, or the strip board, cut to size. We got 22 across, even though we only need 19, and I don't know, over to T, which is 20 or something like that, more than we need on that side as well, because you want to leave some extra in case you want to run the flying leads, run leads off one more mount hole, or whether you want to actually drill some mounting holes for screws or that sort of thing. So you don't want to cut your strip board exactly to the size of the circuit. You want a little leeway. You certainly don't want to end up with too little. I mean, you might have to adjust the circuit at some point, depending on component sizes and where you source things. So the next thing we'll do is cut the traces. Now, there's a variety of ways you can do this. I think there's even a specific tool you can get to do this. For me, the last one I did, and I haven't done Vero board too often. I cut 2 of these. Now I'm trying to find where I put it. Okay, here's the other one, just so you see. You want to keep these little cutoffs in case you need them for some other circuit. We'll put those aside. I did do a test somewhere, but I'm not really seeing it, so I'll just do another one. I'll take the smallest one. So the last time, as I was saying, the last time I did this, I just grabbed whatever was at hand, because you really just have to break the bus line. And what I did was I took an X-Acto knife like this, and I just went in the hole that I needed to cut and twisted a bunch. And you can see that you know, it's not the cleanest, but that's gonna take a chunk out, and that's gonna cut the bus line there, short it out, and that's what we need for all those things marked cut. Now, I mean, that works. A little bit of manual labor there. Another way to do it that a lot of people use is a drill, and this is I think a 3/32 bit, and you just want a bit that is big enough to break the bus, but not so big as it interferes with the mount holes on either side of the cut. So you just put it into the bus, and that's it. Obviously, it's a lot cleaner than the X-Acto knife method, but there's a lot of methods to do that. We really just have to cut the bus line in the spots indicated on the diagram. So speaking of spots indicated on the diagram, we've got the diagram here, and we've got 17 cuts. Now, one of the things that has been somewhat confusing for me on these Vero boards is the way that they're laid out, in the sense that you're going to want to mount the components, you know, to this side of the strip board, whereas you're going to solder on the other side. Basic point is, I guess it has numbers on both sides. I kind of want to do the cuts where I can see the bus line, and that would be like this, but that's not how the layout is displayed. Like, the layout is displayed like the other side, where I can't actually see the bus lines, but they are there. So we'll just do it this way, I guess, even though I really want to look at these while I'm cutting them to make sure that I'm cutting along the right way, but we'll do it this way, because that's probably the proper way, my feelings aside. So what I'll do is I'll mark the cuts with a Sharpie, and then we'll go ahead and cut them. So this first one is on the 4th bus, and it's the 3rd in. So thankfully they're numbered depending on how you cut. You might have the numbers that line up. You can see them there at the top, and there's letters on the other axes. So again, we want the 3rd column and the 4th row. So 1, 2, 3, 4, and the 3rd row. I'm just triple checking this because you can't go back. 1, 2, 3, 4, and the 3rd column. So there's one right there. I haven't done this with the Sharpie before, so we'll see how it works out. I kind of want a red Sharpie because on the diagrams they're red, but this will do. So then we go skip 2, and then there's another cut. Alright, so then I like doing these related to each other because it's kind of easier to find them that way. So we skip 3, and then there's 1. So skip 3, and then 1. Right, and then there's a little triangle of them there. So that one, that one. Then from this one, we skip 4. Right, 1, 2, 3, 4. 1, 2, 3, 4, and then it's the next one, and then it's 3 in a row. 1, 2, 3. Okay. And then we want to go back, so we want to skip a row, and then there's 2. 1, 2. Then we want to skip a column and go down 1 row from there, which would be here. And it's just 1. Then we want to skip 2. That's down there. Now you'll see where I basically have 3 extra bus lines, and that's fine. I can cut those off later if I need the room, or I can just leave them on. It doesn't affect anything if we don't use them. So this one we want to jump over is 1, 2, 3, 4, 1, 2, 3, 4, and then 1. That's good. So this one, we can relate it to these 3, so we want to go over 1, 2, and it's on the 3rd, and skip 1 up. 1, 2, it's on the 3rd, skip 1, and here. Sorry about all the mumbling, it's how I'm keeping track. I'm navigating the board here. Okay, so that one we want to skip 2, and then there. Almost done. I want to go up 1, 2, 3, 4, and it's on the 5th, and 1 back. 1, 2, 3, 4, it's on the 5th, and 1 back. Down to 1 left, and that is 1, 2, 3, 4, 5, 6, and it's on the 7th. 1, 2, 3, 4, 5, 6, 7th. 1, 2, 3, 4, 5, 6, 7th, and it should be 3 down, which it is. Okay. So now I'll just count them up. There should be 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So that looks good. I'm going to go ahead and, I'll cut a couple on camera, and then I'll cut the rest off camera. The other thing that gets me a little squirrely about cutting from this side is that you're pushing into you're pushing the traces up. So I don't know. It's probably not a big concern, but theoretically you could push up more of the bus traces off the board than just the hole you're cutting. But we'll go slow and see how it works. There's 2. I'll go ahead and stop the camera and I'll do the rest. Okay, so I've drilled out the 2 boards. Kind of drilled one, and then I stacked them and drilled through to the other. So in that way you could do a bunch of these. At the same time, I never really realized that. And it turns out my concerns about drilling through the back, as I call it, I'm not sure what you'd call the back or the front, were somewhat justified, because when I did drill through, it did push up. Instead of actually cutting some of the traces, it just pushed them up a bit. Little remnants, little flaps. So I had to go around with the X-Acto knife just to kind of cut some of the leftover bits. Just gently, and I saved a couple here. You can see there's some leftover traces or trace bits there. You could go over these cuts with your voltmeter, or sorry, your multimeter, to ensure that that they're all indeed cut. That would be the diligent way of doing this, because it could become much harder when you put components into the circuit and they start affecting the resistance or continuity between these points. So you know what, maybe we'll do that quickly just to check a couple, just for sanity's sake. Also should probably double check the spacing here, because don't want to do a lot of work and then find out one of these is wrong. So we've got down 3, then 1, then skip 2, then 2, over 3, then we have 1, 2, 3, down 4, 1, 2, 3, 4, then we have 3 in a row, skip 1, down 2, over 1, we have that, skip 2, that, skip 4, that, skip 2, that, and then up 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, over, then we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so that looks good so far. So flip it back over and we'll check some of these just to be sure. This is my fluke meter, which my dad gave me and I use all the time, so thanks, Dad. This is just going to beep when we have continuity, so I'll trace a bus that I know is good, and then we'll go on either side of some of these holes. It's looking good so far. This is pretty quick, so maybe this is worth doing every time. Looks like none of them are shorted so far, knock on wood. Yeah, and then that one's connected. So I think we're good. I'm going to go ahead and assume that the other one is good as well. So we have our cuts done. Now, that's our 17 cuts. We want to do our 5 links now. And they just have them with black wire here. Some folks do them with bare wire. I still like to do them with insulated. Get this out of the way for now, and we'll bring out our trusty circuit board holder. We'll do these one at a time. I'm not sure if I should bother using colored wire for this. Probably not. These circuit board holders are great. You should definitely get one. They're like $10 off of Amazon. I'll post a link. They allow you to hold a vast variety of size circuit boards and rotate them for access. Okay, so I might have to move one because I think, well, depending. No, I got space over here, so we should have access. Now, I think they're all in black on this diagram, so you know what? I'm just going to stick with that. Just grab a length of black solid core. I got my iron heated up. Maybe we'll place them all first, and then. So you're going to want for this some wire strippers. These ones are much better than the other type, which that's so descriptive. I used to have another set here of the simpler type that's just kind of snips almost, that have a little stop so they don't snip the whole thing, and a little notch so you can strip the wire. But these ones are great. I highly recommend them. So let's strip off one end and we'll bend it and we'll figure out where our first one goes. So our first one is 1, 2, 3, 4. It's the 5th down from our first. So let me double check that. 1, 2, 3, 4. Yeah, it's the 5th down. So 1, 2, 3, 4, 5. So let's count that again. 1, 2, 3, 4, 5. Pop that in there, and then it goes 1, 2, 3, 4, and it's 5 long. So 1, 2, 3, 4, 5 long. So just right there. So you know what? I'll grab it there. That didn't quite work. We'll try it this way. 1, 2, 3, 4, 5. And well, actually we'll do 5 this way. That's a bit easier. 1, 2, 3, 4, 5. So hopefully That's the amount that we want to strip off. Didn't quite catch. And I'll bend it down. I might have to strip off some more, but we'll see. Just check it up here. Whoops. Yeah, I think I made it a bit too long. We'll get the hang of this. I said I haven't done so many of these Veros. 1, 2, 3, 4, 5. So that's the 5. We're close, we're close. So just a little more insulation off and then it'll be good. I should really snip a second one to this length because I'll need it for the second pedal. And put that aside. Okay. So, let's see how this sits in. I find these wire strippers are pretty good for bending. I also have, you know, some of these flat needle nose that are good for bending, also good for placing. So if we're 5 down from here, 1, 2, 3, 4, 5, and 5 down from that. So 1, 2, 3, 4, 5. So that looks pretty good. Just push that down, flatten it out, and then kind of flare the leads out with my fingers so it stays in place when we turn it upside down. So that looks good. So I'm gonna wait and solder them all at the same time. So our next one is quite long. It goes from the ground, our last row here, which I guess is 17, all the way up to the top. Now usually one of those is power and one of them's a ground bus, but I guess we probably have a break. No, we don't have a break, so I guess this one's a little different. We got a ground at the top and a ground at the bottom, and 9 volts is along the center there. Ground, and then a ground up top, and then a 9-volt bus along the center. So this runs along all these cuts in the middle. So I'll look for these 3, and then we're going from 1 to 17. So from 1 to 17. So that should be good. We'll cut that, and then I'll cut another for our other pedal. Put that aside. Okay, trim that. So 1, 2. This is actually a bit long, but that's fine. So where do we need to trim it? It is 1 below that hole. So we want it basically right there. Is that going to catch? I'll get my other pliers. This is one way of doing it, so we'll try it. I'm experimenting here. Like I said, I haven't done that many of these stripboard builds, so some of the processes of measuring and all that we're still working out. So we'll see if this works out. You want to make sure when you're bending wire right where it enters your circuit or your board or whatnot, that you want to bend it after the insulation. What happens is if you actually bend the insulation, then it will melt and it'll reform, and it looks really sloppy. It'll kind of bow up a bit, the insulation I mean, once you solder in, because the heat makes it want to undo the bend, and we don't want that. So you want to bend outside the insulation. So we've got a couple small ones here. The next one is 1, 2, 3, 4, 5. So 5, so this is interesting. 1, 2, 3, 4, 5. So we know how long a 5 is, more or less. It's this one, so we need 2 more of those, and then we need to drop the wire. Okay. So put 1, 2 down there, I guess. And we'll strip this off. Strip. bend. And where does this one go? 2 over and 2 up from that cut. So 2 over and 2 up. So it looks like there, right? That's 1, 2 there, 1, 2. 1, 2, 1, 2, and then it is 1, 2, 3, 4, 5, as I suspected, or as I looked at before. 1, 2, 3, 4, 5. So grab it there, pop it out, and then I'll bend it there. That works pretty good. I mean, it's a bit annoying stripping after it's bent, but the bending, it just marks the spot. It gets unbent a little, and we'll pop it back into place. So 2 over, 2 up, with a span of 5. 1, 2, 3, 4, 5. Flare out. Okay, I'll just do the. How many more are there? There's 5, and we've done 4. So I'll go ahead and do the next 2 off camera, and then maybe the other board, and then I'll come back. Okay, we've got the links done on that board and this board as well. I was surprised at how many I misplaced. I had to adjust them. I don't know if you noticed, but a little while back, I believe this one, once I measured, I placed it here instead. So you definitely want to double check these. At least for me, it's very easy for me to measure them and then strip them and then put them in the wrong spot after identifying the correct spot earlier. So definitely double check, and it's kind of good to have 2 boards actually, because then I can check them against each other and against the diagram to make sure that everything's in the right place. So now we'll solder these links. This is pretty quick compared to soldering components. This is hopefully a walk in the park. These buses are pretty close together, so you got to be careful not to use too much solder or to get too much solder on the leads. You certainly don't want too short between bus strips, because that would defeat the whole purpose of the circuit. Unknown things would happen. There we go. That's it. Got my trusty flush cutters. Let's start trimming. I have a little pill bottle, I suppose, or something was in there that I used to just dump trimmings in. Some of them are long enough to use for jumpers on other projects. Some of them are just gonna eventually get thrown out, but it's better than dumping them on the workbench or letting them fall on the floor, which I've certainly done enough of over the years. Said it in a previous video, you definitely want to have some of these flush cutters. Again, they're cheap. Get them off Amazon. I think these are, I want to say Hakko, I don't know how you pronounce it, but they're inexpensive and they do a great job as long as you only use them for trimming leads. If you start using them for whatever you have to cut, you'll find out that they do dull and snap. So that one's soldered up. To save time, I'll just stop the camera and I'll solder up the other one quick. Okay, we've got both boards soldered up. That one took a little header. I'll try to remember not to do that. I'm setting them up like this so that I can populate them at the same time. Even if that one falls out, it should be fine to, you know, the bandsaw is not that precise. This one's a bit smaller. Maybe I could put a shim in there, but this should be good, at least to populate them, because you know, I'm going to be getting components of the same value, so I may as well do them both at the same time. So I like to bend my components with these needle nose. You can get these types of bending jigs, I guess you would call them, but I find I can get cleaner bends with my needle nose, and especially something like this where the distances are not necessarily uniform, you know, between components, because they have to cross a bunch of bridges. Some projects you'll find everything, you know, is the same spacing, whereas here, because components have to cross a variety of buses, they're going to be vastly different lead lengths. Sorry, my color's a bit off on that printout, so I'm going to pull it up on a screen just to the side of me as well to see. So we're going to do resistors first. You want to do resistors because they sit low on the board, and you want to populate the lowest components first, because some of the higher components will block access to those low spots. So the first one I see is a 390R. I'm just going to go left to right here and skip the capacitors for now. So 390R, which is just, you know, 390 ohms. Got this. I've already measured these out, so I need 2 of these, 1 for each. And it's going to sit across two buses and mount on the other 2, and that's 1 in from the bottom. So let's see. So it's going to sit across those 2, I believe. So I basically have to bend it right at the resistor, it looks like, which is fine. That makes it easy. Just grab them, bend in, down. I mean, you can mount these resistors sitting upright. You know, I haven't done that in the past. I actually kind of like the look of it, but it's just not my, hasn't been my MO. So I'm not going to do it here. But what I mean is, you could bend a lead all the way around like that, and have the resistor, I'll just pop it in here, kind of sticking up like that. And if you say needed to populate this resistor, you know, across with that spacing, just 2 holes, you know, one bus length apart, then I guess you would have to do it that way. But this one is not that tightly spaced, so we'll just do it the more common way, I would think. So I'm using the links as a reference too, so you can see it's 1 below this link, crosses over 2, and it's in that one. So it's 1 below the link, crosses over 1, 2, 1, 2, and it's in that one. Okay. Our next one is a 100K. This 100K at the top here starts at the ground bus, skips 3, and then goes in. So let's find my 100Ks. $220, 10K, 1K. Pretty sure I had these all laid out. 100K, there we are. 100K with some crazy writing. Okay, so I need 2 of these at least. Potentially more. Might come across later. I did go through all the parts, obviously, you know, to gather them, but I'm not sure how many. I'd have to look at my parts list to see how many 100Ks that we need so that I could put them all aside instead of just taking 2. So again, we're starting 1, 2, 3 in, and it's going to skip 1, 2, 3. So 3 in, 1, 2, 3, and it's going to skip 3. There's a. Are we? Yeah, and it's supposed to go over a cut there. So that's right. You can't really see the cuts as well when components are over them on the on this diagram. So you kind of have to cross-reference, but you can just barely see the cut under there. Now, so do the other board. So let's see, 3 and across the cut. So I'm going to go ahead and populate the rest of the resistors. There's not much to talk about along the way, so I'll stop the camera and I'll be back when the resistors are populated. Okay, got the resistors populated. It's more than I thought, but that's fine. This takes a little longer. Now it's time to solder them up. It's not a whole lot to talk about here. I guess they're not going to sit upside down proper. I'll just solder one then the other. I'll just do a couple. One of the things I was going to mention was that, you know, I didn't populate this board centrally. I wanted to take advantage of the numbers and start from 1. But what that means is that, you know, there's extra space on one side of the board, but there's no extra space really on the other side because I started at 1. If I kind of transposed the layout, started on 3, then I'd have a bit of space on either side of the board to do mount holes or whatnot. You know, I don't have any specific plans of using that space, but it would be nicer to have it centered on the board rather than kind of offset, which it is currently because of that. So just a note that if you want to have, say, mount holes on all 4 corners or something like that, then you're going to want to offset the layout, and then you'll have to keep that in mind if you're using the numbers on the board, you know, to assist you in laying things out. I mean, if you're not using the numbers, it doesn't really matter. And to be honest, I didn't use the numbers really anyway. You know, I lay things out more relatively, you know, counting over and up from the last component rather than absolutely from the numbered planes on the board. So you don't need to watch me solder all these, and then the second board, it doesn't look like there's anything all that interesting, you know, soldering these resistors. I do like the tag board. This is my second tag board, sorry, not tag board, stripboard project, because the spacing is you get used to bending a resistor that has to cross over 2 buses, bending a resistor that has to cross over 3 buses, 4 buses. It ends up being these standard sizes, and that can go quite quickly. So I'm going to stop the camera, and then I'll solder up all these resistors, and then we'll move on to capacitors or something. Okay, we've got the resistors all soldered up. Now, one of the things to note is if you flared the leads out, depending, a lot of them cross over, and if you're not careful, you can get these blobs of solder, these solder joints, a little too close together. Sometimes they'll even combine. If they do that, you know, you want to trim the leads. You want to run your soldering iron between the 2 blobs and kind of pull up. If you need to use the solder sucker one of these things to pull the solder out. Do that, heat it up, pop it out, resolder, and then to check, if you think something's a little too close, I'll run an X-Acto knife between the two buses just to make sure there's no little bits of solder or residue there, and you can usually feel, if it's smooth, there's nothing there, then there's a path through. If your X-Acto knife kind of catches, or you feel some chunkiness there, then you might have a problem with the solder crossing over. Like this one here seems a little close, so I'm just gonna reheat it and push the lead over a bit so that it's not so close to the other bus. I'll check it again, and it also depends how you trim the leads, which angle you use the flush cutters at to get kind of the best clearance between buses. So I think we're looking pretty good on both. So now, what else do we have on this? We've got sockets, we've got some capacitors, some diodes. So the diodes are pretty small. We'll do those first, I guess. We can see those here, D1, D2, D3, and D4. Now, the layout called for 1N914s, but I didn't have any of those, so I'm going to use 4148s, which are supposedly equivalent. I've got lots of those, so I'll need 4 per board. So quite a few diodes. Now for diodes, they have a little black line on them on one side, and that black line will show on the circuit diagram. So you just have to line up the little black lines for diodes. Where's this first one? So they cross over 2 traces. That should be good, I would think. So where's the first one? Starts at the top of the 390R, and then it crosses 2, so it's right here, crosses 2 to there, and the other one goes the opposite way across the same space. Easy peasy. I'll do another 2. I could space those out more in case there's any heat issues, so they're not right beside each other, but that's fine. We'll just leave it like this because they're already in. So the D3 goes right up against the hole and crosses over 2 again. So we're up against a cut. You can use these cuts as reference. And the other one, again, is the opposite way up there. There we go. Quite see it. So you know what, I have this here. I'm just going to go ahead and solder these, just double check the positioning, and then I'll do the other board. Diodes, but for 4 components here, I'll just solder them as I go rather than populate the other board. So for Vero board and strip board, you're going to want a nice fine soldering iron tip. You can see that this tip is pretty precise. It really comes in handy if you're just buying what I guess we used to call, you know, Radio Shack $10 soldering irons. The tip is not going to be that precise. It's going to be relatively blunt, and that can be problematic. We're trying to do some of the detailed work, like keep the solder from flowing between the buses on a board like this. So for $40 you can get a nice Weller iron that gives you some options as far as tips and replacement tips. You can get these nice tips for fine detailed work. So that one got a bit close. Just see, I might want to reheat that one just to get it off the space between the bus there. I don't even know if that was one of the ones I did right now, but that's better, nice and clear. I don't think it was actually. Maybe it was. Okay, there we go. We got our diodes in place. So I'll go do the diodes for the other board, and I'll be back. Okay, now we got the diodes all populated. We're going to move on to capacitors, I think. What else? We're running out of components to put on, which is great. So 100N is our first caps to put on. How many 100 nanofarads do we have? 100. We only need one of those. Although, I don't know how that could be. Oh, that's 100U. We need 6 of 100N. So I got this kit of capacitors from DigiKey that I was going to use for this because it's nice and easy. It's got, you know, our little compartments, and then it's got a legend of them. So I might need my capacitor cheat sheet, which looks like this. Shows all the codes and all the values. So 100 nanofarads. 100 nanofarads is 10,000 pico, but 100, I'm pretty sure I have 100 NF in this kit. Yeah, I don't think we need 200 volts. We have 100 NF, 100 volts, 100, I guess that might be it. Oh, 100 NF, 50 volts, that'll do. So we need 6 of those for one pedal. That's quite a few. Is that right? 1, 2, 3, 4, 5, 6 it is. Wow, so we need 12 of them. So, I'm not sure how many are in here. Maybe not enough, but we can substitute some others. So, the first one goes up here. And it's going to start at the cut beside our resistors and cross 1 like that. Looks pretty good. The second one is going to start at the 390R resistor, and again it's going to cross 1. So right here. Okay, I like these. These are, as they say, they're automotive grade, high operating temperature, radial leaded multi-layer ceramic caps. That all sounds great. So we may as well put in the rest of the 100 ends. So we're going to cross the 20, start at this, what's going on here? So it's below that one, leave a space. This is confusing me now. Oh, I see why, because the capacitor actually crosses over this cut. That's why you can't see the cut underneath it, so it's kind of a little confusing to look at. And then another one starting at the base of the 12K resistor. And again, it's going to cross one. Yes, that's where we are. So where are the rest of them going? 100N starts at the cut over here and crosses one again. These ones sit really nice at this spacing. We'll see if everything's crossing one. So kitty corner here and crossover. So how many we got there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. That's 6. Okay, and we got 4 more. So I'm going to have to probably use one of the higher value ones for the other pedal, which is fine. So I'm going to go ahead and solder these in, populate the other pedal, solder those in, and we'll move on to the next set of resistors. So I've soldered one, oops, and populated the next. And what I wanted to point out was I started flaring the leads to the sides along the bus lines. That way they're less likely to overlap onto another bus line or put you know, just get a little too close when you solder them to the neighboring bus lines. So by flaring them to the sides, they actually, you know, can actually help the conductivity of the bus lines. If you were to lift a trace or something like that, you could actually use the lead to just continue along the bus line, which I might actually do here, because one of these resistors soldered a little problematic right there, so I can actually use the lead from this, one of the leads from this round of capacitors, to overlap onto the damaged solder pad, and make sure that that is conducting the way that it should. So just a little dab there. That's good. Excuse me. So I guess maybe at some point I should talk about a fume extractor, which I do not have. I should get one, and that's to prevent inhalation of the soldering fumes, which depending on the solder can be detrimental to your health in the long term or short term. I'm not really sure. Okay. So what's our next value of resistor or capacitor? Sorry. Got our 100 N's in. That was a lot of them. So there's three N9s, which is kind of an odd value. So I had to actually order some. You can swap those resistors out or capacitors out. It's actually suggested that you do that and experiment with the sounds. You could socket these socket these capacitors so that you could switch them on the fly if you wanted to try out new sounds. But for now, I'm just going to go by the diagram and 3.9 ends, we need 2 per. So I actually have a different set, so I could put different ones into the different. I have just enough, I think. I'll have to check those. These might be the 47 ends, so get out another 2. And let's see, where's the first one go? So it goes, oh, there's a 430p, but this one crosses over 1, and it's right beside this cut. So it goes right there, and I'm going to flare the leads along the bus lines. The other 39N, I'm not seeing immediately. Sorry, 3N9. Maybe I'm wrong. Maybe there was only one 3N9. Yeah, I'm not seeing another one, so we'll put that aside. 47N. So 47N is another. Actually, let's do the 430Ps because they're small. I think it's 430P. Yeah, so here we have some 430PFs. We'll put those on as well. And supposedly 430P with 3 per. The 3.9N, there is only one. My mistake. So 3 per, so there's 3, and there's 3 for the other pedal. And we'll just get one of these over here for the other pedal as well. So these ones go. It skips over 2. Is that going to skip over 2? Pretty close. So that goes the same lines to the resistor. I'm going to have to bend these leads out just a little bit. I'm not going to worry too much about this. Is it going to sit there? It's going to sit a little bit high, but that's fine. I don't want to get into bending those leads too much. 430p goes across to down here as well. And it's fine if they sit a bit high off the board. They're so small, that'll help with some heat if there is any. And where's the last one? 430p, 430p, 430p is across this 470. So I'll go ahead and solder these up, populate the other boards, solder those. Things are looking good though. So next we've got some 47Ns, which I also have in this kit, so it makes it easy. I like buying these, a wide variety of components in a single sweep, have them on hand. So 47N, this skips one and goes beside the 100N. Are those the 100Ns? I guess those are. And it ends up one below the 12K, so that's right. These black caps are, I think they have writing on them, but it's really difficult to see. I haven't even tried looking that closely. I don't know if it's gonna show up on the camera either. Okay, so there's one 47N. The other one goes over the 12K resistor beside the cut and skips one hole. Right? Yes. So right there. That's pretty good. So we also might as well think these are 100U electrolytics here. Let me just check to see what they say, because we may as well put that one in while we're at it, since we're only putting in 2 of these 47Ns. Let's just double check. That says 16 volts, 100 UF. So the short lead and the white line are the negative. This one goes beside the cut and down to the negative bus, or the ground bus at the bottom, so that makes it pretty easy. Okay, so now we'll solder those in. Maybe get this guy sitting a bit straighter if I can. Alright, is that straight? That's not straight at all. That's straight. We'll just solder these up. Quickly. Now that the board's getting quite populated, pretty busy, you might find that, you know, some solder flows together along the same bus line. Along the same bus line is all good. Everybody's friends along the bus line, but obviously you don't want it to flow across the bus line, because that's going to have unintended consequences. Sorry about that. Still getting used to having the camera here. Alright, that looks pretty good. Electrolytic stayed pretty straight. I'm going to go ahead and do the same for the second board. So I did the other board, and I realized I had missed one capacitor, this 10N up here, and then there's this particular layout or circuit has a switch you can add to either boost the mids or scoop the mids, and I am going to put that in. I'm just not going to put it in initially. I'll add that later, because it can be on that you can put the caps right on the switch. And that's if you look at this layout, it's down here in the corner. It tells you how to wire that switch to accomplish those that boost. Okay, so the last components to solder on the board are the transistor sockets. Now, for pedals like big muffs and fuzzes and some distortions, folks want to be able to change out the transistors, try different transistors, germanium transistors, vintage transistors, all sorts, to see what kind of sounds they can get. So you get a socket for them. You can get these types of just row of pin sockets, or you can get sockets that are kind of more circular. This layout's meant for these types of sockets, so these are the ones I'm going to use. And let's see, the first one is going to go up here, I think. Now, you can try bending these pins so that they sit and stay in the spot where you put them when you flip the board. To me, these pins, they don't seem bendable to me. I'm afraid they're going to snap. They seem there's other sockets where the pins are bendable. So what I do with these is I'll put my finger to hold one side. Don't hold the side you're going to solder, because you could burn your finger. But get some solder on the tip of your iron, and then solder the pin you're not holding just enough to get it to stay in place, and then you can go ahead and solder the other pins, and then of course it will definitely stay in place because they're fully soldered, and you can resolder the kind of temporary pin. So that's how that goes. I'll do another one. The other one, we got 4 transistors on here. The next one goes down here. Now, excuse me. I've ordered some transistors on eBay, the KT3102Es. Sorry, that's my phone ringing. I'm a bit busy right now holding this transistor, so that's going to have to wait. Yeah, I've ordered some on eBay, but they haven't come in yet. So I'll just use some other transistors in the meantime to test this pedal. I have some, I think it's 3904s. I'll have to check. I'll have something around that'll work. Again, at this point, it's okay if the solder jumps across on the bus line. That's perfectly alright. You just don't want it jumping across 2 different bus lines. So there's 2. I'll put the other 2 in and then solder those, and we'll come back. So now I've got the transistor sockets soldered in to both boards, and I've actually populated one board with transistors. So what I'm going to do now is attach all the leads. So I'm not going to worry about the stomp switch or the power stuff just yet. I'll worry about that when I have the enclosure. So what I'm going to do is I'm going to attach all of the pot or potentiometer leads, volume, tone, and sustain, as well as the input, the output, which I'm not quite seeing here, but I'll figure it out. Maybe it comes off the volume. The power, everything I need to actually test the pedal, and I'll hook up some jacks, some 1/4-inch jacks, and some potentiometers on a breadboard, and I'll test it out, make sure everything works, and then I think I'll do the enclosure in part 2, a second video, and we'll, if everything works, we'll get one or both of these circuits into an enclosure with all the proper hardware. Well, here we've got the finished boards. Actually, I've got both of them. Only one of them has transistors. I haven't populated the second one with transistors yet, or attached the leads to the second one. I figured I'd test out one and then see if we have any changes to make. So you can see I've got power supply connected to our power leads. This is the 9-volt lead, and ground connected to one of the jacks. I've connected the pots up here, and I found on the instructions that it says at the bottom that volume to output. So there wasn't an output listed on the you know, the stripboard layout. That's because the output is from pin 2 of the volume pot, and that's here. So I have that going to the tip of this 1/4-inch jack, and I have the input going, which is here, going to the tip of you know, another 1/4-inch jack, and then I have the pots wired up as instructed on the layout. So, you know, this doesn't have the switching, this doesn't have, you know, an AC adapter or a battery adapter yet. I'll put those in after in part 2 when I do the enclosure. So I'm going to go ahead and turn the power on. Things aren't blowing up. I'm going to go ahead and turn my amp on. And we got a nice hum. I got my SG here. And we've got fuzz. So we can adjust the, I'll have to check to see which is which. This would be the tone pot, I believe. I might get them mixed up. So that doesn't exactly sound right. No, that's the sustain pot. Second one's the tone pot. I like the tone pot the other way. Or then we have the volume pot or the level pot. So, seems like everything's working. So there we have it. Part 2, I'll do the enclosure. We'll put at least one of these pedals in an enclosure and wire up all the hardware. Thanks for watching, and thanks to IVARC and Tagboard Effects. That's where I got the layout from. So we'll see you next time.